Okay, so yesterday's class we have been discussing about exponential of 2 by 2 general matrices and specifically 2 by 2 matrix. So for that purpose what we have been doing is writing down this any general 2 by 2 matrix in terms of Pauli's matrices. So, so I actually asked you to find out something, right? So I asked you to find out what is e power I a dot sigma. So anybody has done this calculation? So what did you get? Yes? Oh, nobody has done. Are you able to hear me?
Yes, sir.
So you are able to hear me, but you have not done this, right? So anyway, if you have any problem in doing this, you get back to me. So I just, because we have clearly mentioned things in your last class. So this is nothing but I cos A plus, so where A is equal to A1 square plus A2 square plus A3 square power 1 by 2 and plus I A dot sigma divided by A sin A. Okay. If you have any issue while doing this particular problem, then you can discuss. Otherwise, you just try once, try and let me know. So maybe in the next tutorial class we can do this. Okay. So this is what e power I a dot sigma equal to. So where earlier we said that A is basically a vector with components a1, a2, a3. They are real numbers. So this one you can easily generalize to a complex numbers also. So I can in general I can write down this is e power alpha dot sigma, because you can substitute IA equal to alpha. So this will come, you can actually in this expression itself you can actually substitute A is equal to suppose you substitute IA equal to alpha. Okay, so you can actually do the calculation. So what we are going to get here is I cos hyperbolic alpha plus alpha dot sigma divided by alpha, where alpha is again is equal to alpha 1 square plus alpha 2 square plus alpha 3 square into sine hyperbolic alpha. So this two things, okay, try to derive. If you have any issues, we will come back to this. So now e power alpha dot sigma, which is equal to this one, and you know that any general matrix I can write 2 by 2 matrix, I can write down in terms of, suppose this is A, and I can write down this matrix in terms of sigmas and the identity matrix. So I can write down this as alpha 0 I, where I is the identity matrix, plus alpha dot sigma, that is nothing but alpha 1 sigma 1 plus alpha 2 sigma 2 plus alpha 3 sigma 3. So this is alpha 0 I plus this one we have seen in the one of the earlier classes. So this is alpha dot sigma. So any general matrix e power a 2 by 2 matrix, I can write it as, so what will be the answer? Because e power alpha dot sigma is equal to this, then what is e power a, where a is equal to alpha 0 I plus alpha dot sigma? Anybody can give me the answer?
Log of
Yeah? Yes? See, e power alpha dot sigma is equal to this, okay? And I just want to find out e power a, where a is alpha 0 I plus alpha dot sigma. The question is e power alpha 0 I plus alpha dot sigma. Whether I can write down this as the question mark, I can write down whether this is equal to e power alpha 0 I plus, not plus, multiplied with e power alpha dot sigma. Can I do that? So e power a plus b, can I write down in this case, which is equal to e power a into e power b? Is it possible here? Yeah, because I can see the mixed answer yes and no. Okay, what you should check, whether it is an operator or matrix or functions or whatever you are talking about. Okay, e power a plus b equal to e power a into e power b. What is the first thing you should check, whether I can write down like that or not? Okay, so what you should do? Yeah, you have to just check. Suppose, see, what you have to do is e power a plus b is equal to e power a into e power b if commutator of a with b is equal to 0. Okay, if the commutator of a with b is 0, then I can write down e power a plus b is equal to e power a into e power b. So here a is alpha 0 identity operator and b is alpha dot sigma. Do they commute each other?
Yes, sir.
Because it's not an identity matrix here, not an operator. So you see, any matrix commutes with the identity matrix or some constant into identity matrix. Okay, so it's always 0. So let me just ask you a few questions here. Okay, so A is a matrix and A is some constant, or say C is some constant number. Okay, what is the commutator of A with C? A is a matrix and C is a number. 0. Because see, this basically commutator basically means AB minus BA. So A into C minus C into A. So a number multiplied with a matrix is same as, means A into some number is same as that number into A. So there is no problem. So this is equal to 0. So that is one aspect, and another one is, already I mentioned that, suppose I have some B identity operator, identity matrix. So A commutes with the identity matrix because this is A into I minus I into A. Okay, so this is 0. So the next question is, if I write down a matrix and some constant into another matrix, so what is this equal to? Can I write down this is equal to C A comma B? Can I do that? Whether A comma C B, is it equal to C into, where C is a number. So can I write it as C into A comma B?
Yes, sir.
Yes, you can do that. So this is, so if A and B commutes, obviously this is equal to 0, otherwise it is not. So instead of B, if I have I, then it is 0. So A with C into I is 0. So, if that is the case, I have 3 matrices A, B, yes.
Sir, what happened if the P will be a complex number in previous question?
Okay, so the previous question, so the question was A some complex number into another matrix B, whether this is equal to that complex number into A comma B. This is your question, right?
Yes, sir.
Yes or no? Others?
Yes, sir.
It is true. Why? Because see, what is this equal to? This is equal to A C B minus C B A, right? So this is number. No, C and A commutes. So I can write down this as C A B minus C B A. So I can take C outside, then I can write it as AB minus BA is A with B. So it does not matter whether it's a real number or a complex number. I can do this. Yeah. Yeah.
C is a complex number, so it is a form of matrix. You can say 2 by 1 matrix.
No, so that's what. So I am not. See, I am now saying C is a number, either complex number or real number. I am not saying C is a matrix. A and B only in matrices. Okay. So now you have a new question. So that is what I am going to do. Okay. Okay. So I have 3 matrices A, B, C. All these 3 are matrices. Okay. So any n by n matrix. Let us look at that way. Now the question is, what is A with BC? Okay. So A matrix, B matrix and C is also matrix. So what is this equal to? By definition of commutator of A with BC, what is this equal to? A, B, C minus B, C, A. Right? So A into BC minus BC into A. Now, can I take B or C outside? No, because in general A and B don't commute, and B and C also do not commute. So because of that reason, I cannot write this as BAC or this as CBA, whatever. I cannot change the position of any of these matrices anywhere, unless suppose B is an identity matrix, I can take it here, no issue. If A and B commutes, need not be identity matrix. Suppose A and B commutes each other, then I can write it as a BAC. But I am taking a general 3 matrices which in general do not commute each other. So I cannot do anything more than this. I can keep it like this. But is there some short, some interesting way of writing this such a way that this is equal to commutator of 2 matrices multiplied with another matrix? Can I do a combination of like that? Yes, the answer is yes. So this is, first let me write down the answer, then you can prove it. Okay. So this is equal to, you write this B first. Okay. B, A, C plus, then C last. Okay. Say A and B. So A commutator with BC is equal to B commutator of A with C plus A commutator of B into C. So can you just, I will give you 2 minutes just to verify this, whether this is equal to, so you just verify that this is equal to ABC minus BCA. Just take 1 minute, not even needed 2 minutes. So this is a very useful formula. Okay, you will come across this later on in when you discuss, even because this algebra goes for the operators also. So you should know this. Okay. So if any, yeah.
Yes, sir.
Yeah. So this
Add and subtract BAC.
you have to add and subtract BAC. Okay. So then you can get that. So this is actually you learn, because how to write that. So ABC. So this one you take it to the left hand side. Then A is the C. Then this one is the last one that you put it in the last one. So now because you know this, what should be A, B with C? Same rule is applicable. So what you should do? You take A first, B with C, plus then B last. Okay. So this formula is very useful. So you will come across that soon. Okay. So coming back to the problem. So I can, because the identity matrix commutes with any matrix, I can write down this e power a plus b is equal to e power a into e power b. So what will be this result then? What will be this equal to? I have to do e power alpha 0 I. So is it an identity matrix, this quantity? Is this quantity a identity matrix? Can you hear me? I think all of you are hungry now, okay? Because you are not speaking today. So okay, so this is e power a is equal to e power alpha 0 I multiplied with e power alpha dot sigma, where e power alpha dot sigma is this, right? So you just write down that quantity. So because this is anyway one matrix, so you don't have to write the identity matrix again, okay? Because this quantity is anyway matrix. Any matrix into identity matrix will be identity matrix. So I can just write down this as cos h alpha plus alpha dot sigma sin h alpha divided by alpha. Now can I simplify this further? What is e power alpha 0 I? Is e power alpha 0 I, is it equal to e power alpha 0 into I?
Yes, sir.
It is, right? Because in the expansion, this term I square, I cube, whatever is coming, everything will be I. I can take it that identity matrix outside. The remaining thing I can write it as e power alpha 0. So finally I can write down this as e power alpha 0. I just put I here. Okay, so let me start I here itself, e power alpha 0. So this one very useful formula, you come across this soon. So any 2 by 2 matrix exponential, you actually basically written as the cos hyperbolic and psi hyperbolic terms as a series expansion. Okay. Yeah.
So there should be bracket, I thought, before cos.
Yes. There is a bracket. Thank you. Okay. So you can actually some matrix is given. Okay. Find the exponential of A and find the eigenvalues and eigenvectors of that matrix. This kind of questions you can actually now you can easily expect. This kind of eigenvalues and eigenvectors of a exponential of a matrix, if that matrix is 2 by 2, sometime it will become very easy to do. Okay, so you think about such problems. Any questions? Yeah.
Consider rotation in 3 dimension, a general rotation in 3 dimension. So you have x cap, y cap, and z cap. Now we want to have a general rotation about a unit vector n cap, which is pointing any direction in space with an angle psi. Okay. So this is what we want to do in general. So Euler's theorem will tell you that we can actually, any general 3-dimensional rotation can be done by a rotation about this axis n cap. Before doing that, we can actually write down a rotation about z axis with an angle psi. So let us write down that as r. Rotation about, so here we call it as z cap. We are rotating about z cap and with an angle psi. So this is, all of you know that this basically when you are rotating about the z axis, so this will be 1, and so this is cos psi, and this is sin psi 0, minus sin psi cos psi 0, 0, 0, 1. So this is basically rotation about the z axis. So similarly, you can write down the rotation about y axis. Okay, let us think about rotation about x axis first. So x axis with an angle psi, which is equal to, so it is about x axis, so 1, 0, 0, 0, cos psi, sin psi 0, minus sin psi cos psi. So, and then rotation about y axis you can write down, which is, this all of you know earlier, so that's why I am not solving these cases, because it is earlier classes you must have studied it. So our y psi is nothing but, so you see, so this will be 1, and these terms will be 0. So this is cos psi, this is minus sin psi, so that difference is there, and sin psi and cos psi. So this is what you are having, and yeah, so the rotation about these 3 axes can be generated by 3 matrices. So in general, a rotation about a general axis n cap with an angle psi, this is what we want to find out. So about the particular x, y and z axis, we already seen that those matrices can be, we can write down easily. But that is not the case when you have the general rotation about a vector n cap, a unit vector n cap. So to get into this, so what we have to do is we want to see, say with the z axis itself, you said that r z, okay, I did not use that notation. So basically r z cap with an angle psi is nothing but, so cos psi, sin psi 0, minus sin psi cos psi 0, 0, 0, 1. So what about the rotation about this with an angle delta psi? So this is, we can easy, so why I am doing this is, we can we can actually get this angle psi from a small infinitesimal rotation delta psi, so that when you put delta psi is equal to 0, this basically, or delta psi tends to 0, the rotation is basically an identity rotation, because identity transformation. The rotation matrix will be basically identity matrix. So you can actually do n such delta. So you can actually do n such delta psi and get into a general rotation angle psi. Okay. So now we will do for our calculation purpose for a infinitesimal rotation delta psi, and then we have to write down this matrix. So that is our idea.
So rotation about the z axis is this only, okay. So there is no issue with that. So I am now saying that you are actually making a very small infinitesimal rotation about z axis, which is delta psi. Delta psi is very, very small, okay. Delta psi tends to 0. So what is this quantity equal to? So you know that, so obviously this is cos delta psi, you have to just substitute sin delta psi 0 minus sin delta psi cos delta psi 0 0 0 1. So you know that when delta psi tends to 0, cos delta psi is 1. So I can write down R z delta psi is equal to the matrix 1. What is sin delta psi? Delta psi, then 0 minus delta psi, then 1 0 0 0 1. Fine? Is that correct?
Yes.
Okay. So I can write down this as, obviously the infinitesimal rotation means identity transformation plus, because you can see this matrix is having already one identity, right? So plus what is the rest of the term? Delta psi minus delta psi, right? There, all other elements are 0 in that, okay? So suppose I write this as I delta psi j, say j z, okay? You write j z. So what is j z equal to? What is the matrix j z equal to? J z should be a matrix. What is j z equal to? So j z is equal to 0 minus I 0 I 0 0 0 0 0. So similarly for x cap, y cap you can get, right? So in the s cap case, I plus I delta psi j as x. In the case of y cap, I plus I delta psi j y. So in that cases, what will happen if it is a jx, which term will exist? What are the terms going to exist? Because this will be minus I, this will be plus I, right? And other case, in the case of y-axis rotation, this will be plus I and this will be minus I. Okay, that you can work out j1, jx, jy and jz. Already jz we have got it here. Okay, so I said that you making n infinitesimal rotation, delta psi rotation. So n delta psi is equal to psi. So then what will be R about z axis you are doing now right now, psi equal to in terms of this. So I should do this how many times? N times I should do this rotation, right? So I should do R z delta psi R z delta psi this n times. So this n times what you get, because R z delta psi is this quantity. So what you get there? Identity plus I delta psi. So delta psi I can write it as psi by n. Okay, and j z power n. Is this clear? So a psi rotation is n times you are doing the delta psi rotations. Then that you will get it as I plus identity matrix plus I psi by n j z power n. So the next question is, suppose n goes to infinity. That means, yeah.
While we are multiplying these small rotations, we can add small rotation and small rotation.
Okay, very good question, very good question. So now I am saying delta psi is tends to 0, that means n going to very large, n tends to infinity. So what is limit n tends to infinity? Identity plus I psi by n j z power n. What is this equal to? E raised to this e raised to I j z. Okay. So rotation about z axis, you can actually, that rotation matrix can be written as e power I z j z. What is j z? J z is this matrix. Okay. So this j z is basically the generator of the rotation. Usually it is an angular momentum. Okay. So angular momentum is a generator of rotation. So similarly, you can easily find out R x cap psi. What will be R x cap psi? E power I psi jx, and R y cap psi will be e power I psi jy. Same procedure. Okay. So you can write down what is jx and jy. So what will be jx? Can somebody can
0, 0, 0, 0, 0, 0, then 0, 0, minus I, 0, then minus I, and 0. Yes, sir.
okay, and in the case of j is y,
0, 0, I, and then minus I.
okay. So do they commute each other? Jx, jy, jz? Do they commute? I mean, whether jx into jy is same as jy into jx?
No, sir.
So they do not commute each other. Okay. So I think time is up. I think I also have some other meeting. So we will start from this in the next class. So that is, you know already these three generators you got, jx, jy, jz. So rotation about x axis, an angle psi can be written as I psi jx, and rotation about y axis, angle psi can be written as e power I psi jy and z psi e power I psi jz. So, in the next class what we are going to do is any arbitrary rotation psi about a axis n, okay, because that can be now can be realized using these three, okay. So, any arbitrary rotation about axis n, now you can write it as j1 n1 plus j2 n2 plus j3 n3, that is basically the dot product of, so where now I can see j, okay. So, j is a now vector, the components are j1, j2, j3. So, why this is a vector? See, because we are calling this is a vector j, where the components are basically the matrices. But the thing is, this vector also, this j vector, which, okay, I use the notation x, y, z, let me use that, x, y, z. So, the components of these vectors are jx, jy, z, they are matrices, still the vector j transforms like a vector under rotation. So, this also, the j also form the same transformation equation, okay, whatever you do for the ordinary vectors. So, because of that reason, the j dot n into psi e power j dot n with I into psi will give you a general rotation. Okay, we will start from this tomorrow. Okay.
Sir?
Yeah.
Sir, you told that if we twist, there will be a quiz or test, some kind of, will be that for